Now that we have our ground rules established, we're going to go ahead and talk about some different properties of exponents. And we're going to kind of figure them out one per video here. So we're going to see where these properties are coming from. On my first problem, I have x to the fourth times x squared. And what I'm going to do here is actually write out my problem with a bunch of x's and see where it takes me. X to the fourth really means x times x times x times x. We're multiplying four x's together. And that's being multiplied times x squared, which is really x times x. So there's my x to the fourth, there's my x squared. If I multiply all those x's together, what I really have there is 6 x's being multiplied. So if I do x to the fourth times x squared, I get x to the sixth. On my second problem, y to the fifth is really y times y times y times y times y. And y to the sixth is going to be y times y times y times y times y times y. All together, I have 11 y's being multiplied. So this is equal to y to the 11th power. On my last one here, these are actually 2's, not z's. But when you have numbers here, we're still going to treat it just like a variable. So this might as well be a z, because all this means is 2 times 2 times 2 times 2. And then 2 times 2 times 2. This is going to equal 2 to the 7th power. So after seeing a couple of these, you guys can hopefully pick up on the pattern here. We did x to the fourth times x to the second. We got x to the sixth, y to the fifth, y to the sixth, y to the 11th, 2 to the fourth, 2 to the third, 2 to the 7th power. It looks like what's happening when you have the pieces side by side like this is we are adding our exponents together. And that is actually the first rule that we're going to talk about, or the first property of exponents we'll discuss. So when the pieces are side by side being multiplied, so here we have x to the m times x to the n. If they're side by side like that, you're going to add your exponents together. So x to the m times x to the n is going to equal x to the m plus n, whatever those variables end up being. And we can take that property and use it to kind of solve a lot of problems here. So on my first example, I have 3a's over here times 5a's over here. So 3a's being multiplied, 5a's being multiplied. In the entire problem, I have 8a's being multiplied together. Similarly, I have 13b's being multiplied, 6 plus 7. So this is going to be the final answer to my first problem then when I simplify the property of using the property of exponents. Now, the thing that kids will do wrong with this sort of problem here is they'll take these numbers, we have a 6, we have a 5 right here, and they get in the habit, oh, when they're side by side, you add. You add the exponents together. This is just a regular 6 here, this is a regular 5 here. You do 6 times 5, just like normal. So if you have numbers out front, the coefficients, you do still multiply those like normal. So I get a big 30 out front, not an 11. Again, it's 6 times 5. Those are just regular numbers. You multiply them like normal. But my exponents here, I have 4 x's, 18 more x's. Altogether, I have 22 x's being multiplied. And I have negative 2 plus 2 for the y's. That gets me a y to the 0. But if you remember, y to the 0 is equal to 1. So I don't even really have to write that if I don't want to. I could, but this is a good final answer as is. 30x to the 22nd. 30 times x to the 22nd. All right, 2 more problems here. Again, however complicated they get, you just take it one variable or one thing at a time. I always like to start with my coefficients here. Negative 4 times 3 is negative 12. Those are coefficients, so I multiply them. M to the third, m to the negative 8th makes an m to the negative 5th. N negative 6, n to the negative 4th makes an n to the negative 10th power. And I'm going to get a p to the positive 9, because I have 12 and negative 3. Now remember from our last video, this is not a final answer like this. You have to actually figure out the final answer without any negative exponents here. So I need to move this guy, Negative 12 is good where it is, p is good where it is. My final answer here is negative 12. It'll be p to the 9th, and on the bottom I'll have m to the 5th, n to the 10th. And this is my final answer. And on my final problem here, again, this is like the last problem on the last one, on the last whiteboard. I have 5 3's being multiplied right here. I have 11 3's over here. Altogether, I have 16 3's being multiplied. When it's underneath the exponent, treat a number just like a weird looking variable. Pretend this was an e or something like that. we have 16 e's being multiplied. You do not do 3 times 3 and get 9 here, because these are the actual things with the base side. These are the exponents. If there was a number out front, you would multiply those, but these you treat it like a variable. You get 3 to the 16th power.